Today, we are diving into a technology that's quietly transforming the way the world communicates, from your smartphone to satellites in orbit, from 5G networks to the front lines of modern warfare. It's called software-defined radio, or SDR. And once you understand what it can do, you might never look at a radio the same way again. For over a century, radios were built as fixed hardware, every frequency, every function hardwired into circuits. If you wanted new features or a different frequency, you needed entirely new equipment. But SDR flips that idea on its head. Instead of locking everything into hardware, it moves many of the key functions like filtering, mixing, and modulation into software. Suddenly, a single device can act like almost any kind of radio just by changing the code that runs it. That means one piece of equipment could support multiple frequency bands, encryption methods, or communication protocols, without ever being taken apart. Need to switch from a police radio network to a secure military channel. With SDR, that's a software update, not a hardware overhaul. And that flexibility is changing the game for everyone, from soldiers to telecom giants to amateur radio hobbyists tinkering in their garages. In the commercial world, SDR is already driving the future of telecommunications. 5G networks, smart cities, IoT devices, all benefit from the fact that SDR can be updated on the fly. Imagine a network that can adapt instantly to new standards without replacing a single turn. For public safety, first responders can communicate seamlessly even if they come from different agencies with different equipment. And in aviation or space, SDR allows satellites, aircraft, and ground stations to speak the same language, even if that language didn't exist when they launched. But it's on the battlefield where SDR's power becomes crystal clear. Imagine a military convoy under electronic attack, enemy jammers trying to cut off communications. With traditional radios, that could mean disaster. But SDR systems can detect interference, switch frequencies, and adjust modulation schemes in seconds, sometimes automatically, thanks to AI-powered cognitive radio technology. These radios don't just survive hostile environments, they adapt to them in real time. Security, of course, is a huge part of the story. Modern SDRs can integrate encryption, anti-jamming measures, and even autonomous spectrum monitoring to keep lines secure. And because it's all in software, upgrades can roll out faster than threats can evolve. That's not just an advantage, in some missions, it's the difference between success and failure. The real magic, though, is interoperability. Think about global peacekeeping missions, different countries, different gear, different standards. SDR makes it possible for all those systems to communicate without replacing fleets of hardware. It's like giving every soldier, ship, or aircraft a translator that learns new languages on demand. Looking ahead, SDR technology is only going to get smarter. With advances in AI, machine learning, and next-general processors, future SDRs will not just react to spectrum changes, they'll predict them. They'll use history, context, and environmental data to optimize communication before a problem even appears. And with trends like massive MIMO, cloud integration, and edge computing, the line between radio hardware and intelligent network infrastructure is blurring fast. Of course, there are challenges, cybersecurity risks, regulatory hurdles, and the complexity of integrating SDR into existing systems. But those challenges